Math 2415, Calculus 3, Section 13.6, Parametric Surfaces and Their Areas, Video 4. Yes, Video 4. Example, find a parametric representation of the sphere x squared plus y squared plus z squared equals a squared. We're assuming a greater than 0 is constant. It could be negative, but why would you make the radius of a sphere negative? That's just silly. Well, what's going to be the easiest way to do this? And again, we're trying to come up with only two parameters to capture this entire sphere. Sphere, spherical, but let's consider spherical coordinates. Recall that in a point in space in spherical coordinates, you have three parts. In order to see them, I need to project this point down to the xy plane. One part is your theta, it's how much you rotate from the positive x-axis. Excuse me, what am I doing? This doesn't have enough axes. It was pretty convenient for a moment there. All right, so let's pick a point in space here, and let's project it down to the x-axis. So let's say that it's right here. Then to get to that point, I need to know three pieces of information in terms of spherical coordinates. I need to know rho, which is the distance from the origin. I need to know theta, which is the rotational angle down in the xy plane. And I need to know phi, which is the tilt angle from the positive z-axis. But recall that in spherical coordinates, rho equals a constant is a sphere. All this is saying is go out A. You can rotate as far as you want, you can tilt as far as you want, all the way down to the South Pole, and you get a sphere. So we can just parameterize x, y, and z in terms of theta and phi by using the spherical coordinates, where x was rho sine phi cosine theta, y was rho sine phi sine theta, and z is rho cosine of phi. Yes, just make sure I had them right. But in this sphere, we already know what rho equals because we're told it's a sphere of radius a. So we can replace all the rho's with a's. Remember, that's not a variable, it's constant. So what are our parameters? Well, phi and theta. So parametrically, we can describe a sphere using the following. We can say the x component is a sine of phi cosine of theta. The y component is a sine of phi sine of theta. And the z component is a cosine of phi. And just for clarity, we can say that theta only has to go between 0 and 2 pi because we make one complete revolution on the xy plane. But remember that the phi only has to go all the way to pi because as a tilt angle, to get from the North Pole to the South Pole, you only have to tilt a half revolution. Going beyond that, it's pointless because you could just go the other direction. So that wasn't too bad. But I wonder what the grid curves look like. Let's talk about the grid curves. I brought this up in a video and we never really talked about it. So let me sketch a sphere here with a radius of a and see if we can figure out what the grid curves look like. Remember that the grid curves are the images of the parameters equal to constants. So for example, let's say theta equals a constant. What would it look like if theta were a constant? In other words, you rotate this, but then you're allowed to tilt up or down as far as you want. Well, we would get a line that looks like this. But if we change that theta, then we would get another line that looks like that. So what do these look like? These are longitude lines. You know, like longitude lines on a globe. Take a wild guess what phi equals a constant would look like. For example, if we held the tilt angle constant. So if we were here and only tilted that far, we could rotate the theta wherever, and our grid lines for phi equals a constant would be latitudes. Lines of latitude. So from a computer perspective, if we were drawing a globe, it would be much easier to draw the longitudes and latitudes than to try to solve that for z, use a plus minus, get the top and bottom, because again, we would lose a lot of the points around the equator depending upon the limitations of the technology, because if we were doing that, then along the equator, the tangent lines are vertical, their slopes are undefined regardless of the plane you look in, and so it would be hard to draw. So that wasn't too bad. Let's take a look at another example.